video, we're going to go over test number 4. So in number 1, it says which statements could be used to prove that triangle ABC and triangle A prime, B prime, C prime are congruent. So what I'm going to do is I'm going to go ahead and draw some pictures, because if you don't draw pictures, it could be absolutely impossible to figure out which can actually prove the triangle's congruent. So I'm going to take it answer choice by answer choice, and I'm going to mark the diagram with the information in the answer choice, and I'm going to see which one actually proves the triangle's congruent. So number 1 says AB congruent to A prime B prime, BC congruent to B prime C prime, and angle A congruent to angle A prime. And looking around, that's SSA, SSA, or backwards, ASS, ASS. And that's not a valid method of proving triangles congruent. So answer choice number 1 is out. Okay, moving on to answer choice number 2. AB is congruent to A prime B prime. Angle A is congruent to angle A prime. And angle C is congruent to angle C prime. Looking around, that's AAS, AAS. And AAS is a valid method of proving triangles congruent. So that is the correct answer choice. That's by AAS. Answer choice 3, just looking at it, it only mentions angles. And we know that AAA is not a valid method of proving triangles congruent. And if you test out answer choice number 4 into your diagram, it will give you SSA again, which is not valid. Vertical angles alone can justify that angles are congruent, because vertical angles are always congruent in every situation. Alternate interior angles are not always congruent. They are only congruent when you have parallel lines cut by a transversal. So you would need some given information about having parallel lines to be able to conclude that alternate interior angles are congruent. We are told that AB is parallel to CD, that angle ABC is congruent to angle CDA, and that we have diagonal AC. And it's asking which method can prove the triangle's congruent. Well, I see the shared side. So far I have an A and I have an S. I need more information. I do have parallel lines, so I'm going to highlight those parallel lines. And anytime I have parallel lines, I'm going to think parallel lines cut by a transversal. And I do see a transversal that intersects. Now I can see my letter Z. And in the corners of that letter Z are my congruent alternate interior angles. Notice how they're inside the lines on different sides of the transversal. So what we have here is angle, angle, side, angle, angle, side. 2 congruent angles followed by a congruent side. We were given here that angle A is congruent to angle EDF, and it has already been proven that AB is congruent to DE. So it says which pair of corresponding parts and triangle congruency method would not prove the triangles congruent. So if I take a look at answer choice 1, it says AC congruent to DF and SAS. SAS, SAS. That works. That does prove the triangle's congruent. That is SAS. So that's not the choice we're looking for. We want the one that's not going to prove the triangle's congruent. Let's take a look at answer choice 2. BC congruent to EF and SAS. SSA, SSA. This isn't SAS. The angle is not in between the two sides. This is SSA, which is not valid. So that's the choice we are looking for. Angle C and angle F would have given you angle, angle, side, which is valid. And angle CBA, congruent to angle FED, would have given you ASA, which is valid as well. We have triangle BAT and triangle CRE. We're told that angle A and angle R are both right angles. I did not draw my diagram nicely. And BA is congruent to CR. And we just need to make up one extra piece of information that would make the triangles congruent. I'm just going to make the hypotenuse congruent. So I'm just going to say that BT is congruent to CE. And that's not SSA because it's a right triangle. That's HL, congruent hypotenuses and a congruent pair of legs. You didn't have to do HL. You could have made up any piece of information that made the triangles congruent. You could have put another angle here and here for ASA. You could have put another angle here and here for AAS. You could have put another side here and here for SAS. Didn't matter. Okay, let me mark my diagram. So in triangle DAB, angle D is X. DAB is 5x minus 30. And DBA is 3x minus 60. We're also told some information about side lengths. AB, this side over here of the triangle, is 6y minus 8. And BC, this side of the triangle over here, is 4y minus 2. First up, it says to find angle D. Oh, and I also forgot another given. BC is congruent to BA. That's important. If a triangle has two congruent sides, we know the angles opposite those sides are also congruent. So across from this congruent side is angle C. Across from this congruent side is angle BAC. So ultimately, these two angles are going to be the same as each other because this is an isosceles triangle. Okay, so now to find angle D. In any triangle, all three angles added together make 180 degrees. So this angle plus this angle plus this angle should make 180 degrees. So that's 3x minus 60 plus x plus 5x minus 30 equals to 180. So that is 4x, so 9x minus 90 is equal to 180. Adding 90 to both sides, we get 9x is equal to 270. And then dividing both sides by 9, we have x is equal to 30. So angle D is represented as x. So angle D is 30 degrees. So I'm going to write that here. Measure of angle D is 30 degrees. Next up is to find the measurement of angle BAC. So angle BAC is this angle right here. Let me find the rest of the angles in this triangle first because I can. Then I'll move over to this triangle and answer the questions. So plugging in, 5 times our x value of 30 is 150. Minus 30 is 120 degrees. And then you can plug in your x value here. But if this is 30 and this is 120, this has no choice but to be 30 as well. And that's interesting. In this triangle over here, I see two equal angles. That means it's isosceles. And the congruent sides are located across from the congruent angles. So across from this congruent angle is side AB. And across from this congruent angle is side DA. So the same mark I already have on AB, I'm just also going to put on DA because they are congruent to each other. Okay. Now to find this angle. These two angles are supplementary. So if this one's 120, this one's 60. So the measure of angle BAC is equal to 60 degrees. And that makes this angle have to be 60 degrees because isosceles triangle, two equal angles. And then if this is 60 and this is 60, well, this one's got to be 60 because all the angles in the triangle make 180. And that's interesting because now we know that not only is triangle ABC isosceles, but it's also equilateral. So this side, and this side are all the same as each other. Interesting. That's going to help us out in the next part when we're finding a side length because the next part says we got to find the length of BC. Since we know that in this triangle, all the sides are equal, we can make an equation that says this side, which is 6y plus 8, is equal to this side, which is 4y minus 2. So 6y plus 8 is equal to 4y minus 2. Solving our equation, subtracting 4y from both sides, that's 2y. And subtracting 8 from both sides, sorry, my bad, that's 6y minus 8. So adding 8 to both sides, we have negative 2 plus 8, which is 6. So that makes y equal to 3. So now to find BC, I'm just going to plug in my y value to 4y minus 2. 4 times 3 is 12, minus 2 is 10. So DC is 10. And we said this triangle here, ABC, is equilateral, so all the sides are 10, so AC is 10 as well. And then guess what? We said that triangle DBA is isosceles with the two equal angles, and the equal sides across from the equal angles. So remember, this was one of the equal sides, which is also 10, part of this triangle. And this is the other equal side, which has to be 10 as well. So then we have 20, or the length of DC. Oh, sorry, this was BC. DC is 20. And there we have it. Okay. Over here, we have DG congruent to CG. We have AD congruent to FC. And we have BC congruent to ED. We need to prove that angle B is congruent to angle E. So we have a fill in the blank proof here, so we can kind of use it to help figure out the direction we're going to go in. Sometimes fill in the blank proofs are easier because we can get clues as to the direction we have to go in and as to what goes in each statement and reason. Sometimes they're more difficult because you have to follow somebody else's thought process instead of following your own thought process. So different people like it, some people don't. We'll use it as best as we can. So DG is congruent to CG, that's our given. Our first given, I should say. And let's see what conclusion we're going to draw from this given. We're going to draw the conclusion that angle BCA, let me mark that in my diagram, angle BCA, that's this angle here, is congruent to angle GDC, that's this angle over here. Now, how do we know that? Well, it's because triangle GDC, the small triangle over here, was isosceles. That's what the first given told us, that it had two equal sides. So if we have a triangle with two equal sides, the angles opposite those sides are also congruent. Base angle theorem, but we're not going to write angle theorem. We're going to write it out in words. If two sides of a triangle are congruent, the opposite angles are congruent. There we go. Then we have the rest of our givens over here. And then we have to write down the reflexive postulate. So before I write down the reflexive postulate, because anything is congruent to itself, but I want to make sure I'm writing down something that's going to be helpful in achieving my goal, in proving the big triangle is congruent to prove that angle B is congruent to angle E. So I want to make sure it's something that's important, that's helpful, and not just unnecessary. So looking down a step, I see that we're going to be using addition postulate. And it seems that the goal of our addition postulate is to prove that AC is congruent to FD. AC is the whole side of this triangle, and FD is the whole side of this triangle. To make AC, we're going to be adding AD, and let me get a different color, and DC. So I'm going to put that here, AD plus DC. That makes AC, and that's congruent too. To make FD, we're going to be adding FC and DC. So let me write that here, FC plus DC. Now remember, in order to use our addition postulate, we have to be starting with congruent things and adding congruent things. We do know that AD and FC are congruent from the givens, but we don't yet know that DC is congruent to DC. That makes sense to be our statement for the reflexive property because we need that for the addition postulate. And now We're going to replace the addition with what it is. This plus this is that. This plus this is that to give us the sides of the triangle that we're interested in. So what we're doing here is substitution. We are replacing the addition with what it actually is. And remember that substitution always follows addition or subtraction. So then what we have here is side, angle, side, side, angle, side. And then we know angle B is congruent to angle E by CBCTC. Moving along, we know that AB is perpendicular to BC. That means they form a right angle. DE is perpendicular to EF. That means they form a right angle. BC is parallel to FE. And that AB is congruent to DE. So from our givens, we have a pair of sides and we have a pair of angles, the right angles. We need some more information to prove the triangle's congruent. We do have information about parallel lines. I'm putting parallel lines cut by a transversal. And when I highlight my parallel lines and the transversal that intersects them, I see my letter Z. And in the corners of the letter Z are my congruent alternate interior angles inside the parallel lines on different sides of the transversal. So now I see that I can prove the two triangles congruent with angle, angle, side, angle, angle, side. And then once I know the triangles are congruent, I can prove AC congruent to FD using CPCTC because AC is the side of this top triangle and FD is the corresponding side to it on this bottom triangle. I'm going to pause the video. I'm going to write up the proof and then you can take a look at it. I'm just going to put everything that we mentioned in the plan into the proof. And here's the proof. You can pause the video and take a look at it. Okay, so that was a typo. What we were doing here is proving that the two triangles are congruent to each other. So to prove that triangles are congruent, you do have to show that all of the corresponding sides are equal. So that's using distance formula. I'm going to pause the video and I'm going to do my distance formula calculations. Then I'm going to unpause so you can see them if you need them. Here are my distance formulas. Notice that all of the corresponding sides ended up being the same length from the two different triangles. You can pause to take a look. And remember to include the concluding statement anytime you're writing a coordinate geometry proof. My concluding statement is, since all the corresponding sides are the same, the triangles are congruent.